Now two events are said to be independent if the knowledge of one event happening does not affect the probability of other event happening. Okay, so what I mean by this is, see, now let us say we are talking about independent events. Now let us say we have a coin, fair coin, and it is fair, which means probability of getting a head is equal to 1 by 2, as well as probability of getting a tail is equal to 1 by 2. So equal chances that we get head or tails. Let's say that is the case, that is the kind of coin we have. Now if I toss it 2 times, what is the probability of getting 2 heads? If I toss it 2 times, what is the probability of getting 2 heads? Now I can actually think of it as if it is happening of 2 events. First event is getting a head in the first flip, and the second event is getting a head in the second flip. Now I want to find out the intersection of these two, which means we should get a head in the first flip, as well as we should get a flip in the second head in the second flip. This is the probability I wanted. Now according to conditional probability, what we can write, already we have seen the multiplication theorem. In multiplication theorem, I told you that whenever we have any happening of 2 events, we could use this formula. What is it? Probability of getting a head in the first flip into probability of getting a head in the second flip, given that first flip has already turned out to be a head, right? Now probability of getting a head in the first flip will be nothing but probability of getting a head, which is equal to 1 by 2, as well as probability of getting a head in the second flip, given that first flip is a head, is also equal to probability of getting a head, which means this one is going to be 1 by 2 and this one is going to be 1 by 2. So what I mean to say is, the probability of getting a head, given that already a head has occurred, it didn't change, it didn't increase, or it didn't decrease. Therefore such events are called as independent events. So don't get confused between mutual exclusive events and independent events. Mutual exclusive events are such events in which which actually have the same kind of sample space, but they don't have anything in intersection. That is mutual exclusive events. See this. Now if you have a sample space, if you have 2 events like this and there is nothing in common, they are called mutually independent events, mutual exclusive events, sorry. And what about independent events? Independent events are those events in which we, even though if we know that one event has already occurred, that will not change the probability that other event will occur. Such events are called as independent events. So simple example, if you want to ask, then the example will be flipping a coin 2 times. Now the second time, whatever result you get, that will be completely independent of what has happened in the first time. That is how gambling runs, isn't it? In gambling we have various tables, and outcomes will be random, and the second outcome will never depend on what has happened in the first outcome. If that is the case, if you think that the second outcome depends on what has happened earlier, then it will not be gambling anymore. You will be able to predict the outcome with certainty, right? So independent events are these. What is it? Happening of one event will not tell us anything about happening of the other event, and the probability of the second event happening will not change because the first event has happened. So in order to understand it in terms of the conditional probability formula, you can think of it like this. Let us assume that A and B, these are 2 events. If A and B are 2 events, and if you know that they are independent events, then probability of A happening, given that B has already happened, will still be initial probability of A happening. Similarly, probability of B happening, given that A has already happened, will still be probability of B happening, right, initially, which means here A is independent of B and here B is independent of A. So if A and B are two independent events, then you can think of it like this, then these two formulas will be valid. Now under the light of these new formulas, let's now examine that multiplication theorem. In multiplication theorem, we know that if A and B are two events, then we have already seen this, probability of A into probability of B given A, right? Now assume that these two are independent events. If these two are independent events, then what can we say? Since probability of B given A is equal to probability of B, I am going to substitute it, which means probability of A into probability of B. This is very important. So probability of A given B is equal to probability of A into probability of B. So this is very important formula, probability of A into probability of B, right? So when is it valid? This formula is valid only when A and B are two independent events, right? So if it is given that in a question, if it is given that A and B are two independent events, then what is the probability that A and B will simultaneously occur? Then it is probability of A into probability of B. Now it can even be extended to more than two events. For example, if A, B and C are three independent events, then probability of A, B, C combinedly happening is equal to probability of A into probability of B into probability of C. Got it? So one way to understand it is, if it is already given that A and B are independent events, then we can apply this formula. And the second way is, if you can find out that for any two events this formula holds, then we can declare that they are independent events. It is important. See, understanding this one is easy. So what is it? If any two events are independent, then we can derive this, and from that we can derive this one, right? P of A intersection B equal to P of A into P of B. But then the reverse one is even important. The reverse is, if you find out that for any two events it so happens that P of A intersection B is equal to P of A into P of B, right? Then we can say that if this is the case, if it happens, right, then we can say that the two events are independent. Okay, I'll take examples and explain you, so don't worry. Let's just try to understand only this concept first. What is the concept? Two events are said to be independent if A in P of A intersection B equal to A into B. So now what can I write here is like this. Understand this one. See, two events are said to be independent. I write if and only if, IFF, it is important. If and only if P of A intersection B equal to P of A into P of B. Two events A and B, A comma B, are said to be independent if. So what is the meaning of it? In the question, if they have already given that they are independent, then you can use this formula, or if you can derive that P of A intersection B equal to P of A into P of B, then you can say that they are independent events. Both ways we can apply it. That is what I wanted to tell you, right? So the reverse one is important. So this one is straightforward. If it is given that they are independent, you will directly say that this one is true. But then identifying that without them saying that they are independent events, identifying this one, and then from that you deriving that they are independent is important. Okay, so we'll see questions on both of this. And now, what if you have more than one item is, if you have n elements, n events, E1, E2, E3, so on, En. If you have to say that all these n elements are independent events, then for every subset of this, that formula should hold, multiplication rule should hold, which means if you take probability of Ei intersection Ej intersection so on El, something like this, it should always be probability of Ei into probability of Ej so on into probability of EL, which means if you are having three elements and if you want to say that all those three are independent events, it is not just enough that this one should hold, it should also be holding that P of these two, P of A intersection B should be equal to P of A into P of B, and P of B intersection C should be equal to P of B into P of C, and similarly P of A intersection C should be equal to P of A into P of C, all of them, and even this one should hold. So what I mean to say is, if you have n elements, if you take any subset of these n elements, right, you have to take two set elements, three set elements, and then four elements. Any of them if you take and if you apply the intersection, this multiplication rule should hold. Then only we can say that these n elements are independent. In general, we will not be getting questions about more than two elements events. Generally they will be asking us questions in GATE. If you look at it, generally they will be asking the questions about independent events given only two events. They will not give you 10 events or 3 or 4. In case if they ask you, we can still solve three elements. I'll just take three event examples and I'll explain you. Okay, let's look at the examples, that way you'll understand it better.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.